Okay, this is our chem video. I'm Kim McGroarty and I'm working with Michael Alfreds, and this is our intermolecular forces video. In this experiment, we will figure out how many drops of water or oil can be held most on this single penny, depending on which one has the strongest bond. Okay, so now we will figure out how many drops of water can be held on this single penny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in total, it could hold 13 drops of water before it gets spread all over the table. Now we will see how many drops of oil can be held on this single penny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, it could hold 9 drops of oil before spreading all over the table. Now, using the concept of like dissolves like, we will determine whether oil is polar or non-polar by dropping them into water. So now you can see that the oil floats on top of the water, making the oil non-polar. Okay, water is a bent molecule with polar OH bonds, and the vectors indicate H2O is polar, like here. We have O, both H's. O is partially negative, as the two H's are partially positive, and the vectors then point to the O, as the electron negativity always points to the negative. And it has 8 total valence electrons, so these two lines right here point that we have 2 so far, and then we need 4 more. So we have 1, 2, 3, 4 to finish it off, making this polar. The nitrogen atom is more electron negative, and therefore the valence electrons are near them more often. The hydrogen atom at the bottom of the structure are the more positive, therefore H2O is a polar molecule. Water, H2O, is a polar solvent, and vegetable oil is a non-polar solvent. The contents of the microcentrifuge tube will be mixed with the two solvents. Oil is non-polar because it does not dissolve in water. When it is mixed with the water, it just floats instead. The intermolecular force that holds water together is hydrogen bonding because it has hydrogen in it, and hydrogen bonding is the strongest bond there is, which is why water had the most drops of it on the penny. Oil's intermolecular force is dispersion, which is why it had the least amount of drops on the penny, which is why it broke so early. Given the two contents we worked with, water and oil, the penny was able to hold more water because within water has more positive and negative charges in it, which gives it the ability to stick to itself on the penny. However, oil does not have all the positive and negative charges within it, which is why it's, you can say, looser, which is why it broke off the penny so much earlier than the water did.